Hello, and welcome to another problem video for our pre-preparation class. I'm John Golden, and today we have two geometry problems. In these geometry problems, we'll be using area formulas, thinking about triangles, Pythagorean theorem, all different kinds of stuff. So it's a pretty good application in terms of when you start the problem, you might not know what information you're going to need to access. Okay, so our first problem up here, and like usually, want to start with trying to read it precisely. So a 6-foot spruce tree is planted 15 feet away from a lighted street light. This is an odd situation, whose lamp is 18 feet above the ground. That's pretty tall for a street light. How many feet long is the shadow of the tree? Okay. All right. So we are trying to find this distance. All right. So I'm going to give it a name. You can call it anything you want. We could call it S for shadow. Traditionally, of course, X. It's been my experience that students feel more comfortable with X because then they're used to the kind of the situation of having to find it. Now, I had a student who had a technique that she felt like really helped her, so I want to share that with you. She'd take these more complicated diagrams and break them up into two different diagrams, right? So, because really we want to see two triangles here. There's this little triangle and then the bigger triangle, okay? And these two triangles are similar, which means we should be trying to think of them as proportional. Okay, so we know they're similar. This kind of situation of a smaller triangle and a bigger triangle makes it so that we know that, well, this angle is exactly the same angle in both of them. This one is a right angle for both. And if two of the angles are the same in a triangle, then you know the third angles are the same because every triangle has to add up to 180 degrees. So if this is the same, that's the same. What's left over has to both be the same. So if all the angles are the same, they're similar, mathematically similar, which means we want to think about them being proportional. So a proportion in mathematics is when we've got two equal fractions, right? Or another way to think about it is that the one is so many times bigger than the other. Well, in this case, we can see, right, how many times bigger is it? 18 from 6, it's got to be 3 times bigger. Okay, which means this length over here is going to be 3 times whatever the shadow length we're trying to find is. So we could write down an equation right away. 15 plus x, this length, the length in the big triangle, is 3 times that length in the small triangle. Okay, so then it becomes a pretty easy algebraic equation to solve. Okay, and I'm just going to check quickly to see if there's any unit trickiness. So 6 foot, feet, everything is in feet. So 7.5 is our answer there, right? So this is a dangerous one in particular to wonder if we could go from the picture. Let's just try. They made this 18 look about 3 times as tall as the tree. So if this was 7.5, 15, that's 2 times 7.5. So that means the whole thing together is 3 times 7.5. Oh, well, thinking about it that way, right, if the whole thing is 3 times, and this is it, this must be 2 times. So I could have done it without any algebra whatsoever if I realized that this must be 2 times bigger than this, because together it's 3 times bigger. All right, but say that those kinds of things didn't occur to you. You just see, okay, similar triangles, that means a proportion. So if you're making out these proportion with the fractions, we just have to make sure that things correspond. There's literally 6 different ways that you can fill this out correctly. But they all go by comparing the appropriate thing to the appropriate thing. So, like for one way to put it, we could say 6 is to 18 as the same as this x we're looking for is to, well, the 6 is in the small triangle and the x is in the small triangle. 18 is in the big triangle. So we've got to do in the big triangle. That's the 15 plus x. Okay, so that looks a little messier to solve, but we know the algebra will work out because it's going to be the same thing as here. But you can try to rewrite the proportion in terms of arranging the variables the way you want. Okay, so if we've got small triangle, big triangle, the distance on the ground, then the other number we've got is the 6, right? So that makes this one about the small triangle, and then this one's about the big triangle, so that number here is 18. Okay, so let's get some fresh ground to solve this on. How do you solve an equation like this? So you can multiply both things to get rid of the denominators. So let's see, if we multiply both sides by 6, that'd get rid of this one, but not that one. So let's multiply both sides by 18. So this case we'll have 18 divided by 6 times this x. So we'll get the 3x like we had before. And in this case we've got the x plus 15. 18 divided by 18, that's 1. We've got these two terms together being multiplied, so I'm being careful by showing parentheses. Okay, and that's that same equation we solved before. So it's still 7.5. Okay, many different ways to do those similar triangle problems. So looking at that, just seems reasonable. What you don't want to do is guess, like this distance looks longer than the 6, and kind of pick your answer that way. You want to be doing that proportional thinking. Okay, our second geometry problem is in a different situation. We're given a purely geometric figure and then asked to figure out an area. Okay, so some of these things I know right away, right? So can't be right, because if I chop this apart, well, in the middle here I've got a rectangle that's 10 by 4. So that's going to be 40 units squared right away. Right, so 36 is right out. Okay, and then I've got these two triangles. So I can think about them kind of fitting together to make a rectangle. It's 4 tall, and I just need to know the width. Or I could find them each separately using the triangle formula, right? So the area of a triangle, it's one of those things that's given on the formula sheet for the pre or for the ACT, but is one you might remember anyway, right? So we need a base and a height. We do not have a base and a height, right? So if we think about this is the base, we don't know this height. If we think about this is the base, we don't know this height. So we've got to figure out, whichever way, we've got to figure out this side, because the base and the height are always perpendicular to each other. So this 5 and the 4 won't work. And some of these answers on the side might be trying to kind of tease us into just using the 5 and the 4 directly. Okay, so if we've got this triangle, how can we figure out this third side? Okay, well, by giving us this height, they're letting us know it's a right angle. Right angles, that's always going to mean thinking Pythagorean theorem if we're looking for lengths. So a squared plus b squared equals c squared, but it might be hard to keep track of a, b, and c, especially in a diagram where they're using it for something else. So remember, leg squared plus leg squared is hypotenuse squared. So the leg, one of the legs here is what we're looking for. We want to know this distance. So x squared plus 4 squared, it's the other leg, is the hypotenuse squared. Well, maybe at this point you recognize, oh, this is a famous triangle, 3, 4, 5 triangle. It's okay if you don't. X squared plus 16 is 25. Subtract 16 from both sides. Now we'd usually say x equals positive 3 or negative 3, but we're dealing with a geometric situation, so we don't need the negative solution. Regardless, this distance is 3, this distance is 3. So 3 times 4 is 12. Half of 12 is 6, but we've got 2 of those triangles. So our area is going to be 40 plus 6 plus 6. That's this 52. Okay. If we had thought about it as the rectangle instead, we've got a rectangle 4 by 3, so that's 12. So our answer would have been 40 plus 12. Okay. Maybe you have good memory for formulas, or you notice it on the sheet, and you think, oh, trapezoid, there's a formula for the area of a trapezoid. It's the average of the bases, so it's the average of 10 and 3 plus 10 plus 3, 16, times the height. So half of 26 is 13, 13 times 4, that's a deck of cards, 52. So any way we cut it up, we get the same answer, 52. But again, so many different ways to do it. So connecting this to a way that you feel the most comfortable with is going to get you closest to the right answer right away. Okay? Thanks. Hope helped thinking about these two geometry problems. And remember, make suggestions. Remember office hours, online office hours, Monday evenings, regular office hours during the week, and also I'm very flexible for arranging to meet. And remember the excellent resource of the Math Lab. Go in there, try to find somebody to work with. There's always tutors available to help, but do problems and talk them over with somebody. It's the best way to get through this. Thanks very much, and I'll talk to you next time.